Hello, everyone, and welcome. I am your moderator, Sabrina, and I'm happy to be bringing you another live webinar. Today, we are hosting a joint webinar, and we are joined by AP Tech. So before we kick things off, I do want to highlight a few housekeeping items. So how to ask questions of our presenters. Use the questions pane on your control panel, and we've dedicated some time at the end of this presentation to review that together. Also, all attendees are on mute, so hopefully you can hear our presenters loud and clear. So let me introduce you to today's speakers. From AP Tech, I have Matt, who's a CWT and the Vice President of Sales. He brings over 20 years of industrial water treatment experience to the table and is here to discuss solid chemistry. Also joining us on the line is Tom Tinney, who is our Product Support and Technical Services Manager. Tom is well versed in the nuances of the industry and is a great resource to have. And he has brought along some install examples to share with you today as well. So Matt is going to get us started, and I will pass the microphone over to you and we can begin.
All righty. Thank you, Sabrina. Thank you all for joining us today. Thank you, AquaPhoenix, for collaborating on this webinar. It's been a fun experience, and look forward to getting into the content. So I'll talk a little bit about AP Tech for those of you that don't know us. We have been manufacturing solid water treatment chemicals for over 20 years. We are the global leader in solid water chemistry, distributing to all parts of the globe. Certainly have a great footprint here in the US, North America. As we've grown, this is our third expansion here in Cincinnati, so we've moved 3 times to get to where we're at today. In that kind of expansion over time, while core water treatment certainly is what we have done, what we will continue to do and evolve our product line offering technologies around, we have diversified and added some additional capabilities and product technologies and advancements that I think are really cool. And if you want to learn more about that, certainly feel free to reach out. So we'll touch on what solid chemistry is for those of you who don't have experience with solid chemistry or have only used solid chemistry maybe in a handful of applications or haven't done it in quite some time. So you need to think about solid chemistry somewhat similarly to liquids in the sense of what's in it. Solid chemistry is going to be using the same types of raw materials that liquid programs are utilizing. One key thing with solid chemistry is that we're using best available technologies, both on, let's say, the polymeric side of things to even just the supply chain, partnering with great suppliers to get us the best raw materials on the market. And we've got a proprietary process for taking those raw materials and generating a wide variety of formulations. We've made over 100 formulations in our 20 years, and also product forms. So we have ongoing, continuously used chemistry that utilizes dissolvers, but we also have products like tablets and stick form and BXD boxes that offer up supplemental or feed as needed type of chemistry. The weight of solid chemistry when you're kind of looking at liquid equivalents is significantly less. Our packaging can range from a few pounds up to 48 pounds. So depending on what you're buying, the form it's in, the application, it's in a very easy to handle, ergonomically safe to utilize, move around packaging. So some examples, we have our legacy kind of bottle form products. So that's our paste, put into 1 gallon jugs or half gallon jugs. We started casting products in disc form, which allows you to add inventory on the fly. We've got tableting capabilities now, so quite a wide variety. Our range of product applications are going to meet cooling towers, boilers, closed loop, and then certainly some specialty procedures like white rust passivation or pre-cleaning and passivation, things like that. So why use solid chemistry? I think that question is always perspective based, right? There's a lot of different reasons a water treatment would include solid chemistry in their line. And the same thing goes for why end users or customers would want to incorporate a solids program at their facility, whether they're manufacturing goods or they're commercial real estate or institutions, things like that. But I think if you kind of look at it from a high level, the big thing is people want to reduce exposure. Exposure is wide ranging. It could be personal health and safety. It could be risk, litigation. It could be just perception when people are walking through your facility and seeing chemicals applied, things like that, to the elimination of spills and messes and the tidiness of workspaces and work areas. Certainly reducing waste with the wet solid chemistry, you're consuming product to nearly 100% every time you use it. And the packaging it comes in as well. And then a reduction on our environmental footprint, so both carbon and water. So when we talk about reduction of exposure or reducing exposure in the spills, what we're really looking at is material handling like drums, pails, totes. Also the storage of those same types of containers and packaging. And then on the disposal side. We have solid form products. The only time that we have the product in liquid form is at the point of use. So our dissolvers are making solutions or making very limited quantities on demand for application. So we're really reducing that potential for spills and splashing. The PPE requirements certainly reduce. We're not having to fully suit up to transfer, handle, change materials out with solid chemistry. You can move the materials through the workspace fairly easily, hand cart, they can be carried, hand trucks, things like that, but they're relatively innocuous being in fiberboard or pails packaging. It's easy to load our chemistry into the system. We're going to take up less footprint. We're going to have cleaner work environments and feed stations. The other thing is reducing the kind of risk of zero inventory situations. The products can be stored on site safely. You can have months of inventory on hand, ready to go. You're not having to expedite, something that has to ship DOT hazardous from a depot to find how you're going to get that material, liquid material on site. So there's some benefits there from reducing exposure. And then when we look at the waste and emissions side of things, the materials we're packing out in are fully recyclable. So we use a lot of fiberboard. During COVID, fiberboard packaging, exploded because everybody was getting stuff shipped to their house and all that. Solid chemistry can be shipped just about anywhere using any type of freight that you want. UPS, FedEx, so piggybacking on items that are already going into a facility through common carrier or these type of logistical services has benefits in reducing emissions and waste. The water savings, we're not rinsing out packaging to then further recycle or dispose of. Everything is broken down immediately and put into the recycling aspects. We also have the ability to run calculations. It's just simply using what the EPA provides in terms of calculators. But if you look at an equivalent program that's going to be on a liquid program versus a solids program, you can calculate the reductions in fuel energy associated with that over an annualized basis or an extended period of time. So where do you use solid chemistry? I think that's important to understand. The way we look at it, about 70% of end user applications are spread out across what we call commercial and institutional markets. So you have sub-markets broken from that kind of broad coverage. So you have government space, fairly considerable adoption of solid chemistry in those applications, GSA, Department of Defense, you name it. Office building or commercial real estate, while that industry is continuing to evolve these days, Traditionally, solids have found a good home and a good fit inside of commercial real estate. So anything from just space heating, space cooling, things like that. Healthcare, segment of water treatment is certainly exploding, especially on the water safety side of things with water management plans, Legionella mitigation, stuff like that. But you still need chemistry for treating the utility systems for scale, corrosion, microbial. So that market segment continues to expand. And then any educational level from primary education up to post high school, so colleges, universities, things like that. Certainly a great fit where you have multiple buildings spread out across a campus with isolated utility systems where just getting product to those locations is a challenge. What's growing, I feel is going to continue to grow, is the adoption of solids in the industrial space. So middle market, general manufacturing to kind of specialized areas of food production, so F&B, parts and components supporting transportation, wire mills, you name it. A lot of these corporations are finding benefits, especially as they're expanding and using up all the footprint that they have within their walls, that to shoehorn in a chemical treatment program, solids fit very well. Our products do handle high stress applications. They're robust, so there's no reason they don't fit in that space. Continuing on, so we've talked about kind of physically where and kind of what markets the products go, solid chemistry goes into, but we also think there needs to be a combination of qualitative and quantitative considerations. So we spent some time generating what we call best fit guides for cooling, boiler, and closed loop applications. So it's taking all the sustainability, all the safety considerations, footprint considerations, and just the types of equipment that you're treating, and puts it into a really easy to kind of review guide to say, boy, if I'm 5,000 gallons per day of blowdown or less in this cooling tower application, and I got these other things like, logistically how we're going to get product there, and I start checking these boxes, you can see that that's an ideal fit. So this is to try to help you decide, where should I be thinking solids all the time? Where do I think that, hey, there's enough interest here that we can make it work, and what considerations are to be made. So those are available. On top of that, we built some cost calculators to compare program costs, kind of the full rolled up costs to service, maintain, to deal with chemical handling, all that, and to give a true fair assessment. We have some other tools like Solid Guide to help build budgets, to look up where, equipment bulletins or chemical bulletins, calculators, stuff like that. So a lot of supporting materials to kind of help guide you to understand where to utilize solids at. And you can see we talked about the markets that solids are certainly deployed across a wide variety of institutions, corporations, and things like that. So we'll touch on how to use solid chemistry. I think solid chemistry has certainly evolved. While solids have been around for decades and a lot of different shapes and forms, for those of you who've been in water treatment for longer than I have. But as we look at it, it certainly has evolved. So it's the form it's in, the formulations themselves, and the complexity formulations to go after more and more challenging applications, to the dissolver technology. All of that has kind of gotten us to where we're at today. So this is the current state of dissolver technology. It's our UltraM. In the past, we had rotationally molded equipment that fit bottle form. There was, it was kind of taking a technology from other industries to fit for water treatment purposes. So what we've done is really taken the art of making safe solutions, and it's evolved out in this UltraM. It's a fairly basic design. We've got an inlet assembly on the upper right there with a pressure regulator. There's a level control valve with the white sand weight that's in there. And essentially, when that unit needs solution to be made, the water sprays, it contacts whether it's the disc form, which is represented here, or up into the bottle, rapidly dissolves the product, the chemistry. It collects in this reservoir, and then you use a chemical feed pump to extract the material out. You'll always have solution in this unit as long as you have positive pressure to the control valve. It's self-regulating, it's instantaneous. You can confirm solution strengths by pulling samples and running conductivity testing. The nice thing with the disc form product now is that you're able to stack it, and at any given time, as long as there's room in the dissolver, you can add product on the fly and maintain positive inventory. So along with the UltraM, so the UltraM is all high density polyethylene, it's titanium, it's Hastelloy, it's polypropylene, it's all corrosion resistant materials. It's very minimal spare parts, an inlet assembly, a control valve. You can get replacement reservoirs, lids, but it's relatively low cost, and it's relatively easy to kind of troubleshoot and to maintain. There's not a lot of working parts. If you do have something that's an issue, you're able to change it out in fairly short order. With the multiple piece design that we have, you can easily break the unit down, clean it out, store it for the winter months if it's a kind of seasonally operated system, do your maintenance, get it back up and running. Very simple versus some of the past. And then we do have some other dissolvers available to replace legacy items that you might have seen. We have a two gravity dissolvers, the Ultra G, which has a relay that plugs into a timer or I'm sorry, a step down transfer plugs in a relay or timer. We also have a standalone timer version with the Ultra T. So we've added some flexibility to allow you to kind of put solids in a wide variety of applications. Another big thing that I don't know if enough people really realize or utilize is the ability to couple dissolvers. The UltraM, for a single product, you can actually have double the amount of inventory of a single dissolver by using a coupler kit. So what's that do? It gives you 40 pounds of scaling corrosion inhibitor for a cooling tower on hand. It could double your biocide, it could double your dispersants, it could double, pretty much any of the chemistries that are coming in bottle or disc form. So it's something to consider for higher use applications. It's very easy to install. It keeps the units drawing chemical equally. And then lastly, this will kind of segue into Tom's part of the presentation, but I did want to touch on this, is don't think of having to do anything really functionally different with a solid program than a liquid program. You're still going to do proportional feed to flow, whether it's makeup or blowdown. You're still going to consider percent time. You're still going to do slug dosing on a 28-day biocide timer. You can still use sensor-specific technologies like photometers, ORP, halogen, pH, things like that to feed, control, monitor, whatever kind of methodology that you want. And that all can be integrated into remote monitoring. So keep that in mind as we move in. You're going to take the best of all that available technology that's out there. So at this time, I'll transition over to Tom to take on the second half of the presentation.
Oh. Hey, it's Tom Tinney. Can everybody see my screen? Sabrina?
Yep.
Did my screen come up? Okay, cool. Hey, so I'm with AquaPhoenix. I'm with the equipment division out of the Grand Prairie office. We, of course, have 3 offices. One's in Pennsylvania. That they handle a lot of our test kits and also educational and other industries we serve. We also have an equipment division out in California that handles tanks and that sort of stuff. glycol feeders and the wall chem distributorship. So we've got our feed in it. We pretty much, if it touches water and serves the professional water treater, we want to be involved with it. So that's what we do. Let's see here. All right. So I'd like to talk to you folks about the panel systems that we've been doing with the UltraM. We're really happy with how these things have turned out. So what we can do now is take the UltraMs, mount them on a large panel system, and a couple of things we've done that I think are a little more unique, and we put some thought into this, is by mounting the UltraM side by side, we bring in a primary leg, which would be your feed water source. Now, some folks like to use the tower water to feed the water into the UltraM, your choice. We like to use the city water. The reason we like to use the city water is there's less chance of the biofouling and the other things of incidents that are occurring in your cooling tower coming into your UltraM's feed system, where we're feeding the water in. So we like to use the city water. We also always put some sort of a mesh strainer on there. The UltraM has a little tiny screen in it, and if you clog over or foul over that screen, you will have lessened your performance, and it's a little bit of a bear to rebuild. So by having some sort of mesh or strainer ahead of it that you flush on a regular basis, you're going to reduce that maintenance issue. But as you can see, and of course afterwards, or the other side of the setup is we've got a pump shelf. You're going to put your pumps down here, and then you can actually take the tower loop, bring it in, past your sensors, past any sort of back check, bring it into injection points. So these ones are actually the lower leg are feed water points. The upper leg we're injecting it into the system. And this sort of setup is really nice, really professional looking. We can actually mount this on a frame, and in the underside of it, we can put a cabinetized system in there that lets you then store your solid feed chemicals underneath in that area. Looks very professional. Of course, you have a locking cabinet to keep the people who want to help themselves to stuff when they shouldn't out. So it's a nice setup. And of course, with modern controllers, like Matt had mentioned, you add a modem or some sort of remote communications, and now you're able to monitor the entire system. Also, you can have monitoring on the pump outputs. You guys know this feed verification that lets you know that things are going okay as well. So it's a really nice setup. It's really professional looking. I'm going to show you a couple of examples of some units that one of our customers, don't be offended, but have used. So this is a 6x that we built. We were able to private label it. You can see what he did was he did what Matt had talked about. If you look at these first two, they're actually combined for output. Second one, combined for output. Third one, combined for output. So technically, this is 3 feeds, but he's got the dual dual feeders set up to do that. This is our feed line. It's a city water feed line coming through the strainer, and that's actually going into it. So that's a really nice setup. I think it looks really professional, and it's if you hang it on your wall, your customer can't not be happy. This is a smaller system, a little 2x. Now these are independent. These aren't the systems that we talked about where we can actually integrate the controller and the cooling tower leg onto the same panel. So you can have them separate, or you can have them on the same panel. But I think it's a great way to go. So that's kind of what that's my entire shot here. The equipment's straight ahead. It's stuff that we've been doing for a while, and we like the way that the UltraM is set up that allows us to build these panels. One of the things that also these can be set at, of course, mounted, so that you ease your service ability. I mean, popping it open, you can put everything at the right height, so that you can actually take care of the business, and you're not overextending, and you don't have to put them down really low either. So, and that's kind of it for me. Any questions?
Thank you, Tom. I just wanted to point out as a reminder to type those questions into the questions pane of your control panel. We have time for Q&A, so we're going to hang out for a couple of minutes while you submit your questions, and we'll run through those together.
So one of the first questions is, what sort of maintenance is required on the feeders, like regular maintenance, I'm assuming?
Yeah, great question. So on the feeders themselves, I mean, they're designed for multiple years of operation. The valve itself has a high cycle time. So, that's a mechanical device. So it does, wear over time. It's got a diaphragm in there and some other things. But ultimately, from a functionality standpoint, those have years of life in terms of their expected life endurance. But certainly things happen, things wear, just like on chemical feed pumps and other, piece of equipment you have. So you just want to check, confirm functionality periodically of that. You can isolate the unit, lift the upper section off. You can exercise the yoke and confirm that you've got, good functionality there. The reservoir itself, there may be over time, some solids that might accumulate or just some debris and things like that. That's easy enough to clean and rinse out, but that's typically not needed to be done but once a year. The inlet assembly, you've got a pressure regulator. So there's really not a lot of true maintenance. It's just general confirmation of the functionality, checking for leaks and things like that. But other than that, the parts are easy to swap out. We try to make everything to take 5 minutes to 10 minutes to do the work to handle any of those type of issues.
Cool. Very good. Let's see here. Here's another good question. I like this one. Does moisture ever solidify the chemical stored in the feeder, such as converting powder to more of a brick and therefore clogging the feeder?
So we only have so I guess the way I look at this, we only have a few products that are in actually granular form. Those would be the biocides. Under normal conditions, because the product is contained within the bottles, the granules, there's typically not an issue with bridging, especially if the product use rate is such that your inventory turnover is sufficient. You're using a bottle every month or a bottle every couple months. So it's not usual that happens, but extreme environment storage conditions could certainly. So if you're storing product in very high heat and high humidity, that can have an impact like it would, but it's not common. The paste form products certainly hold up very well, even if you're in humid conditions. They typically are very stable, but we do advise folks that you do want to try your best to store product in environmentally controlled conditions when you can. And so that's the nice thing about solids is they can be stored just about anywhere safely. So you can always find locations for that.
Awesome. Another question. Explain how the PTSA correlates to actives when you're mixing in your PTSA fluorescence with your chemistry. So what's the correlation between it?
Yeah, so it's a couple of different things. So the ratio that we utilize in solids, because our dosages are typically 4 to 8 times less than what a liquid product dosage would be. So if you're feeding a product at 100 parts per million as a liquid, typically the PTSA is 100 parts per billion. So it's formulated in to correlate 1-to-1 part per million to part per million or part per billion. In solids, it's 4 parts per billion per part per million product. So it's a 4-to-1 ratio, and most of it. That covers our average dosing of our products for scale and corrosion inhibitors, which is around 25 parts per million. Some cases it can be less than that. So running detailed water analyses, looking at scaling, doing modeling can actually optimize and get you even improved dosage rates. But it's 4-to-1, and your controller packages, the Pyxis or whatever fluorometer and whatever controller technology you utilize should be able to be set up to manage and feed and control.
Cool. Hey, and a quick sidebar on the PTSA. Whenever you're entering into a PTSA program, do not go immediately to the PTSA sensor controlling it as you transition in. You're better off running it on whatever your current method was, either by water meter or time, for a couple of 3 weeks, so that the chemistry transitions over. And once you've built up some sort of residual, again, doing it the old method, then you flip over to PTSA, so you just don't hammer and go through a lot of chemistry that you don't really need, just so you can catch up on your fluorescence. So just something to think about.
Great point, and it just gives you an opportunity to confirm, validate. I did that in my career as well, and it made sense. So you transition to more full control once you've got everything lined out. A beautiful thing about solid chemistry is we have supplemental products to help boost chemistry fast. So all of our scale and corrosion inhibitors come in stick form, so you could manually slug dose the system very safely and very quickly to achieve product boosts in short order. So instead of taking a liquid formulation, either running the pump for 10 hours or 4 hours or 3 hours, or trying to figure out a way to transfer a product into a container that then transfer into the system, our supplemental products are really nice for that. So loss of feed, loss of control. The discs themselves can be utilized as supplemental, manual dosing as well. They dissolve rapidly. So little tricks like that help you expedite transition. And if you happen to be transitioning from liquids to solids, it's fairly seamless to do that transition because you're able to get the solid chemistry system going, work down the liquids, and then transition over. One point I did want to make, Tom, that you had touched on, we do recommend only makeup water for that system for the dissolvers. So whatever quality water you're using as makeup, whether it's boiler makeup or cooling tower makeup, we want that to be the same best quality pre-treated water. Some of the old dissolvers could technically use or tolerate cooling tower water or more stressed waters. But with the design we have today and the optimization of the dissolver technology, I wanted to emphasize that the panel you're showing here is a beautiful way to set this up with the makeup water header, the inline strainer, and then the drops to the units.
Yeah, I've seen some guys, some people still want to use the cooling tower because they, whatever for convenience. But yeah, if you want to succeed, the makeup water is the absolute right way to go. A quick question on the makeup water: what sort of pressure do I have to have on that line to feed into the UltraM?
It's really around, it's about a 20 PSIG or dynamic pressure at the dissolver. The regulator handles dropping pressure to what we desire for dissolution. So I'd say 20 PSIG is going to be your minimum supply pressure.
What's your max? What's your max before you start running into problems?
The components I think are rated up to 125 or 150, okay. But I always use the rule of thumb is if you could get to 100 PSI or less, it just helps reduce hammer and other things you might experience. So if you're in a high pressure inlet, you may want to have a supplemental pressure regulator, but the inlet assembly and all the components are rated for higher, but I'm a conservative on that side, and I say 100 PSI, and you might want to regulate a little further upstream.
So when we talk about the city water feed again, are there hardness limits or anything like that? Or we're really, because of the openness and stuff, we're really not going to be affected by sort of any of the constituencies in city water? That's why we prefer the city water, correct?
Yes, that's correct. You also have exposure to the halogen, so high halogen levels. You've got total suspended solids. You got all those other variables and wildcards that are out there in the cycled tower water or stressed water source. So, well water we've used extensively on these dissolvers, 500 ppm total hardness, things like that. But you need to keep an eye on it because when they aren't running for periods of time, things are already reaching saturation that, if you haven't run the units because of seasonal things, higher stressed waters, you'll want to maybe flush or do some, general considerations around laying them up. If they're regularly used and water's moving and flowing, then it's less of a concern. The other thing, Tom, on these panel mounts for you guys is the flexibility. This shows a 4-product program. That's probably your extreme, right? It could be a boiler, this is cooling tower, but boiler chemistries might go to 4 products, or you might have a more stressed cooling water application where you need dispersant, non-ox, ox, and scale and corrosion inhibitor. But you can go single, double, triple. There's a lot of flexibility there. You can do standalone panels where the dissolvers and pump shelf, and the one example was there, the integrated solutions. So it really is trying to simplify and make it plug and play for any of you folks where you go to the end user and say, you know what, I'm going to get you converted to solids. I'm going to bring everything in. All we got to do is tie to, get the tie points made,
Yep.
get power, and we're in good shape. So.
Yeah, this system could have been 2 feeding 1 chemistry, like we talked about the split, and the other ones are just singles. So it's whatever combination that the end user needs or the facility needs to match their chemical demands. So it's all very cool. Hey, I got a question here about the presentation. You can actually download the presentation, folks. I believe, Sabrina, afterwards it's still going to be a link to it so you can pull the whole presentation down. Is that correct?
Yes, I will email the group with the on-demand recording as well as the presentation, and then you can reply to that email if you need anything additional from us.
And there's another question in here about brochures. We are going to put together some brochures that'll come out in part of our newsletter. So if you guys subscribe to our newsletter, we'll let you guys know when those brochures are available. We're going to try to do some nicer pictures. We've done a lot of these systems. Some of them are a little crazier than usual. But yeah, we can do brochures with just the solid feeders and the 1, 2, 3, 4 layout, and then the solid feeder with the chemical or with the controller, with a coupon rack, with that entire arrangement that we can do as a kind of the big boy, and then on a frame as well. A frame with a cabinet underneath is kind of another way to go as well. So yeah, the brochures will be coming out. We just don't have any available right now. But if you have a particular application you'd like to discuss, of course you can call AquaPhoenix anytime. Our entire quoting crew can start walking through it with you and basically produce a similar drawing to this for that system for you. So that's always available. But yeah, we will have brochures coming out. I have here another question. Have these dissolvers been used with hydrated lime for any wastewater treatment?
Yeah, great question. You don't know how many times we get asked about really out of the box thinking on solids. We absolutely love it because we know our customers are thinking about how to make solids kind of even more widely adopted. Wastewater, we don't have, we wouldn't recommend hydrated lime or using this for any type of lime addition. There are certainly other technologies out there in the marketplace for that. We do have a couple products that do provide pH adjust. It really comes down to neutralization on that. So if you need alkalinity or you need to reduce alkalinity, so acid or caustic, we have products to do it. People have done it successfully, but it really comes down to a demand standpoint. We're not going to neutralize highly alkaline waste streams well with this, but if you needed to trim pH down and a customer is already really interested or has adopted solids, there are some creative ways to do it. And we continue to look at other applications with solid chemistry. So it's ever evolving. We're continuing to push the envelope there, and hopefully we'll be able to meet some needs in the future for some of these kind of unique opportunities or applications.
Cool. Another question. In the event of float failure, is there any sort of secondary containment or safety measure that keeps it from overflowing out of the UltraM? I think the UltraM is pretty much sealed all the way around though, correct?
Yeah, there's an overflow standpipe. So offset from the chemical solution outlet is a 1/2 inch female MPT port, and it has so it's threaded male to hose barb to 1/2 inch hose barb connection. So it's best practices to kind of direct any of the overflow to maybe a common discharge pipe to go to a local floor drain. Otherwise, if the local environment's conducive for that, it would just overflow water because at that point you'd be low. So off on these drawings here that you could integrate an overflow on that. Other people have done what they've done is they've done some cutoffs on the inlet. You can wire in a solenoid valve and maybe like a little overflow indicator. So if you wanted to, you could integrate that into the controls package. It's not, it's just something to be mindful of is if it did happen to stick open. With the UltraM design, it's less of an issue because it typically fails to close, but there is a potential for a little bit of that. So I would just take that into consideration on the install.
Well, and like I said, if you we talked about this now 5 times, and I'm happy to say it another 10 times. if you're using the city water with some sort of pre-filtration, the likelihood that you're going to get something that's going to really screw up your float is less. So,
Yes.
you know, that's where you reduce that versus something that's going to get in there and jam it up over time.
That's correct.
All right. I think, one more question. What is the solid to liquid comparison?
Oh, great
Not
question.
sure.
Yeah. So,
Good.
traditionally, looking at some of the formulated liquid products that are out there, especially scale and corrosion inhibitors, since cooling water, makes up probably, 60, 70% of most people's business and applications out there in kind of this marketplace. We typically looked at a 44 to, or so pounds of solid product is close to what a drum would be. It does vary on the product specific to the application, but it's typically about 4 to 8 to 1 comparison on that. So I would say a case to a case and a half of solid scale and corrosion inhibitor to roughly a drum is a good starting point, and then you optimize from there.
Cool. All right, I think we have, and we got some more. Oh, nope, there we go. APX used Little Dipper, APS used the Pyxis, which is better. Okay, well that's an opinion thing. So the Little Dipper and the Pyxis are used for PTSA. It's a choice. I know that the Turner does not have temperature compensation in it, and it also doesn't have kind of the ability to pick up and mathematically take care of turbidity. Whereas the Pyxis was specifically designed around having that. So we have focused a lot more on the Pyxis of late, but it really boils down to preference and the ability to handle the maintenance and that you're getting the desired results. So, I mean, it's 60-40, which way you want to go and what your organization is comfortable with, the Little Dipper versus the PTSA. Regardless of which one you do, you are sending a UV beam through a quartz glass that is going to get covered over with gunk and slime and little bits of things, and you are going to regularly clean it, or you're going to inject chemistry at the wrong levels, and the default down is when you see less PTSA, you want to bring more PTSA in. If you blind off the sensor, that's a lot less PTA the sensor thinks. So you're going to overfeed your chemistry because you're not cleaning the glass, not cleaning the viewer. So it is a regular maintenance item. It is part of the program, and it's something you should probably do every month. Both sensors come with an easy remove tee. Pull it out, swab or clean, use the recommended cleaning method from each of the manufacturers, those PTSA sensors every month. So, and I will go back to the old Tom Tenney forever and a day thing. Whenever you do any sort of recalibration on any sensor, you always look at the raw value first. Don't just go in there and assume that the value that you're seeing should be altered with some sort of calibration, or you, the human being, forcing in a calibration. Look at your raw value. It should be within 15 to 20% of the actual. You should only be using calibration to tweak in a value. And if it's more than 15 to 20% off your raw value, then you have some decisions to make about troubleshooting. That's just the rule. And when everybody starts following that rule, we'll have a lot more successes. Anyways, cool. I think that is, that is the end of the questions that we have. If anybody else got any more questions, you can shoot them in real quick. Other than that, I think we're ready to turn it back to Sabrina.
Yeah. So thank you, Matt. Thank you, Tom. And thank you all for joining us this morning. On your way out, if you could please complete that exit survey and then be on the lookout for an email from me later this afternoon with a summary of our conversation and the recording as well. So on behalf of AquaPhoenix and our presenters, thank you and enjoy the rest of your day. Bye, everyone.